This is the second part of the video for the laws of exponents. Number and quantity. The number system standard, we're going to extend the properties of exponents to rational exponents. So, if I have a to the negative x power, I need to rewrite all negative exponents as a fraction. A negative exponent means the base is on the wrong side of the fraction bar. To change the sign of the exponent, put it on the other side, so it should be on the bottom. So 5 to the negative 2 really means 1 over 5 to the second power, which would be 1 over 25. All I did was convert it to a fraction to make it a positive exponent. My negative exponent should be on the bottom. Negative 3 to the negative third power means 1 over negative 3 to the third power, which would give me 1 over negative 27. Remember, it's the exponent. If the exponent is negative, that's when we change it into a fraction. So let's simplify these. If I have x to the negative fourth, I'm going to change that to a fraction. I'm going to get 1 over x to the fourth. And if I have n to the negative 7, I'm going to change that to a... Let's do another one. 9 to the negative second. Well, that really means 1 over 9 to the second power, which means 1 over 81. Remember, an exponent tells me how many times to multiply the base by itself. 9 to the second power tells me to multiply 9 by 9. Let's do this one. 4 to the negative third power. Well, that means 1 over 4 to the third power. When I simplify that, I'm going to get 1 over 64. Remember, all negative exponents go on the bottom of the fraction. Let's try this one. Negative 8 to the negative second power. Well, since the exponent is negative, I'm going to put that on the denominator. So that's going to give me 1 over negative 8 to the second power. Well, negative 8 times negative 8 is going to give me 1 over 64. Do we understand why it's not negative? The exponent tells me how many times to multiply the base times itself. So negative 8 times negative 8, a negative number times a negative number, gives me a positive number, 1 over 64. Here's another. Negative 2 to the negative third power. My exponent is negative, so it's going to be in the denominator. 1 over negative 2 to the third power. That tells me 1 over negative 2 times negative 2 times negative 2, which I should get 1 over negative 8. With me so far? I hope so. Here's another. Negative 7 to the negative second power. 1 over 49. Why is it positive? Negative 7 times negative 7 gives me positive 49. Let's try another. This time, you tell me the answer. Were you correct? If you were, great job. If you weren't, where'd you go wrong? Now, let's talk about dividing the same basis is equal to subtracting the exponents. So if I have a to the x power over a to the y power, that really just means a y minus x. All I do is subtract the exponents. So if I have 2 to the fifth power over 2 to the third power, that just means I have 2 to the second power. Here's a visual example. 3 of my 2's are going to cancel out. That just leaves me 2 times 2. Here's another. A to the x, y, a to the y. If we divide in bases with the same exponent, they'll cancel each other out. 2 to the third power over 2 to the third power, just going to give me 1. Here's a visual. Because 2 times 2 times 2 is going to give me 8 on the top and the bottom. 8 over 8 equals 1. Let's try this one. Negative 2a to the 6 over b to the third, divided by negative 6a to the second, b to the third. Remember when we were multiplying, we separated everything in its own parentheses? Well, as we're doing these, we're going to do the same thing. We're going to write each similar base as its own fraction. So I got negative 2 over negative 6, a to the 6 over a to the second, b to the third over b to the third. So we're going to reduce the fractions first. Reduce the numerical fraction. Negative 2 divided by negative 2, negative 6 divided by negative 2. So my fraction reduces to 1/3. Remember the rules for exponents. If I'm dividing, I subtract them. So a to the 6 minus a to the second is going to give me a to the fourth. And remember, if the bases are the same, it's just going to equal 1. So b to the third times b divided by b to the third. They cancel out. I don't have to put that imaginary 1 there. So my answer is just 1/3 a to the fourth. Let's try this one. Simplify. 20 over negative 5, n to the 7th, divided by n to the first. Remember, if it's nothing there, it's an imaginary 1. 20 divided by negative 5 is 4. N to the 7th minus n to the first is n to the 6th. That's my answer. Try this one. 5 over 10, a over 3 over a over 3. 5 over 10 reduces to 1/2. And my a to the third powers cancel each other out. So my answer is just 1/2. Here's another. Negative 9x to the third y to the ninth over 12x to the second y to the fourth. Make my numbers a fraction, negative 9 over 12. Make my x's a fraction, x to the third over x squared. Make my y's a fraction, y to the ninth over y to the fourth. Let's reduce my numerical fractions. Negative 3 over 4. Let's subtract my x's. X to the third minus x squared is just x. And y to the ninth minus y to the fourth is y to the fifth. Now, there is a mistake on this numerical fraction. We did not divide 9 by 2. We divided them both by 3. Try this one on your own. Is that your answer? If it is, good job. If not, look to see where you made your mistake. How about this one on your own? Did you get that? Good job. Now, when dividing the same base, if the exponent is larger than the denominator, then the base will stay the denominator after subtracting the exponents. So, look, 2 to the third over 2 to the fifth. That's 1 over 2 to the second, because remember, it's going to give me a negative exponent, and I need to turn it into a fraction. Here's a visual. 2 times 2 times 2, 2 times 2 times 2 times 2. 3 of my 2's are going to cancel. Just left me 2 times 2 on the bottom. Try this one. Rewrite each one as similar. Negative 21 over 3. X to the third over x to the sixth. Y to the eighth over y to the second. Reduce the numerical fraction. Negative 21 divided by 3 is 7. Circle the bases with the largest exponent to determine their placement into the above or below the fraction. So, x to the third minus x to the sixth is going to give me x to the negative third, so we know that's going on the bottom. And y to the eighth minus y to the second is going to give me y to the sixth. We know it's going on top. See what we did? Pretty easy, I know. Try this one on your own. that what you got? Good job. How about this one? Is that what you got? If not, where'd you make your mistake? Here's one more. Good job. And another. Not as hard as it seems, is it?